All right, so these are our test type questions for conservation of energy. Zane, want to grab these, bud? And you want to calculate it, right? If you want to plop up front for this, because this is going to be, these questions are on your test, the exact questions, we're just changing the numbers. All right. So, guys, you need to be locked in on this. It means phones away, because you're not doing the calculations on them. Like putting them down in your pocket, in your bag, whatever. They need to go down. Everything that you need in this problem is going to be over here, because I've drawn it out as such. Mechanical energy initially is going to equal the mechanical energy at the end of it. So as much energy as the ball has at any one of these points, it needs to have the same amount of energy at point B. So if we figure the one side of the equation, we can figure out the missing piece on the other side. Okay, now we take mechanical energy, and mechanical energy is kinetic plus potential. The little I stands for what we have at point A initially. The mechanical energy F, all right, the F stands for what it is going to be at point B. Cool thing is, the object that we're dealing with does not change. So the mass, all the M's in these problems, we can cancel out. Okay, so I'm going to write a little note here. Because mass is the same, you can cancel M. What do we use for gravity? What value do we use for gravity, guys? What number? 10. All right, also I'm going to just throw that off on the side. G is equal to 10 in all of these. So because mass is the same, if everybody right now with pencils, we're going to cancel or scribble out the M's. I'm not going to need them. So that takes a bunch of numbers out of the problem. Now we're going to basically use the variables that we have and put the numbers in the correct positions. 1/2 VI squared. So 1/2. All right. What is my VI? Where does it tell me? At point A, what's VI? 12.5. And what do we have to do with VI? Squared. Guys, again, we need to be focusing on this, paying attention, please. Bring down the plus sign. G times HI. HI is here. G is going to be 10. That's our gravity. So 10 times 36. Equal sign. 1/2. See, what is, do we have VF in this? We don't, right? So if we don't have the variable, one of the variables, we're going to let it be. So we're going to write 1/2 VF squared. Bring down our plus sign. What is the value for G? 10. And what is the value for HF? $9.5. So now we just got to make these calculations. You have to do 12.5 squared in your calculator, divided by 2. That's going to come out to give us 78.125. Bring down the plus sign. 10 times 36, 360. Good. Now you're going to bring down the equal sign. We still don't know what this 1/2 VF squared is. So guys, remember, this 1/2 VF squared is basically like a 3x squared. So we need to, once we get towards the end, we need to get rid of the 3 and then also get rid of the square. All right, just keep that in mind. So right now we're going to leave this down as 1/2 VF squared plus, what's 10 times 9.5? 95. Oop. So what I like to do is I like to make sure if I do have 2 numbers on the left side that I add them together. So that's what I'm doing. I'm going to add 78.125 plus 360, and that comes out to be 438.125. Again, I'm bringing down the equal sign. I still don't have VF, so I still have to keep this 1/2 VF squared. Bring down my plus sign. 95. So now, can someone tell me, what do I need to do now if I want this value to be by itself? Where's my mouse? There it is. If I want this by itself, what do I need to do first? Get rid of, yep. Correct. And since the 95, all right, it's not multiplied by it, we're not dividing by 95, you're going to subtract 95 from both sides. Now the number becomes 343.125 is equal to my 1/2 VF squared. All right, so because math is the same, you can cancel. All right, that's 1. Put in your numbers. And multiply. Then add if you can. Subtract if needed. All right, like the 95. Now, to get rid of the 1/2, you must multiply both sides by 2 to get rid of by 2. Sorry. So let me break this back for a second. We'll add that in the next step. Got ahead of myself there. Okay, so to get rid of this 1/2, we got to double both sides. This value becomes 686.25, and that leaves us with just VF squared. All right, now to get VF by itself, square root both sides. So when you square root this side, the square root over here cancels out the squared, and you're just left with VF. So in our calculator, we had the 343.125. To get rid of the 1/2, we had to multiply by 2. We got our 686.25. to get VF by itself, you have to square root both sides. So to square root on this, all right, take the second button. Next to the 7, you should see x squared. Okay, in this blue, the light blue, all right, that means you have to hit the second button in order to access that function. So we would hit second, square root. Darn it, I forgot to write that number down. But if you hit second answer, it takes your answer from that last calculation you just did and then hit equals. And you are going to get an answer for VF of 26, call it 26.2. On this calculator, same thing, right? You had 686.25, cool. To square root that, same thing. Second, where the x squared is, hit that. Second, answer, get the same thing. Now, to go to the next problem. The next problem is done basically the exact same way. All right, they give you a mass, but we don't need it because it's going to be the same thing. The roller coaster carts with however many people are in it. It's telling us, though, that it starts as shown with a velocity of 0 meters per second. So our VI, 0 meters per second. Your initial height is that 45. All right, so initial height. And then over here is our VF. Or I'm sorry, this is our HF, and we're looking for VF.
Is that HI?
This is HI. This is HF. VF is our question mark. So it's done like the problem right above here. This one's just a smidgen easier because something else cancels out. All right, so guys, make sure you are writing everything down as I'm going through it. The M's we get to cancel. All right, from our steps above, same mass, so we can cancel M. Now plop in our information. 1/2, what is VI? 1/2 of 0 squared. Bring down the plus sign. G is how much? 10. Wait till this problem is done, please. HI, 45. Bring now, so the mass is gone, so it's 1/2 VF squared. So guys, all you're literally doing is bringing these guys down here, and if you have one of them, you put that number in for the variable. The only one we don't have is VF. We had VI is 0, so we put it in for VI. G is always 10, so that's good for G. And the initial height, HI, is 45. Okay, we don't have this, so we leave it as. And G is 10. And HF is 30. That's your first step. Now, the next step was, right, after we put in our numbers, we're going to multiply and add if we can. Anything times 0? 0. This is 450. We don't have anything here yet. And 10 times 30, 300. Our next thing, we would add these together, but we don't need to because, yeah, the 0 doesn't do anything. So that would be like the multiply, then add if you can. Subtract if needed. So we definitely need to get rid of the 300 on this side. So 450 minus 300 is 150. And then here, to get rid of 1/2, you must multiply both sides by 2. 150 times 2 is 300. This times 2 gets rid of the 1/2, so you're left with VF squared. To get VF by itself, square root both sides. So square root 300, square root of VF gets rid of this piece here. So in your calculator, we're just doing the square root of 300. .32 and the unit meters per second. The following problem, they give you a mass, but we don't need that because the equation is work is equal to force times distance times cosine of theta. The force that they tell us we pull with, you two, is 165 newtons. The angle that we move distance-wise, all right, we move the distance of 15 meters. And we pulled this at an angle of 30 degrees. All right, so that's theta. And now it's as simple as just putting our numbers where we need it to be. 165 times 15 times cosine of our angle is 30. So I'm going to show you guys how to do cosine on both calculators, whether you have the dark blue or not. I personally always go with the cosine part of it first. So very simple in the dark blue calculators. If you have these, sine, cosine, tangent, you just hit that. Cosine, and then whatever your angle is. Hit equals. Cool. Now, on this one, there's like 2 extra buttons you have to hit. Above the double E, you have the button that's white here. It says PRB, but we want the yellow, the trig. So I would hit second to get to the trig functions, and then go over until I get to cosine, not cosine to the -1. Click on it. Type in my angle. Same number. Beautiful. Now take it and multiply it by 15 and by 165. And so we get a value here of 2,143.41 joules, because joules is the unit for work. Next problem asks, though, how much power would you generate in the problem above if you pulled the block, the 15 meters, in 24 seconds? So again, we don't need anything else but this 15 because they're referring to the part above. So they're just saying if you drag this block 15 meters, but it took you 24 seconds, how much power is that? So power is equal to work divided by time. So you're taking the work from the problem above, taking the work from the problem above, and you are going to divide that stuff by what? 24 is correct. And when we do so, we get a value of 89.31. What is the unit for power? Watts. And then the final question. Damn. Okay, so I need you to understand two things. Well, mechanical energy is equal to potential energy plus kinetic energy. And that the mechanical energy is the same. Oh my goodness, I can't spell words. At every point. So it means no matter what, at one point, all right, if we figured it out, let's say it was 1,000, at the bottom it has to be 1,000, middle it has to be 1,000, at the top it has to be 1,000. Potential and kinetic will change vice versa. Okay. So in these kinds of problems, where he's not moving at the top, the kinetic energy would be equal to 0 joules. The potential energy would all be potential energy at the top. So that means if we knew what the height is at the top, the starting height, if we knew what the starting height was, you could do potential energy is mass times gravity times height to get that. But we don't know what the height is. We don't know what the height is, so we can't do this. Just understanding the concept that at the very top, the mechanical energy is all potential. Well, what about at the bottom as the diver strikes the water? So in this last problem, mechanical energy is equal to potential plus kinetic. It's the same at every point. At the top, we're all potential, no kinetic because we're at rest. At the bottom, which means 0 height, where height would be equal to 0 as you're jumping into the pool. Okay, your potential energy would then be 0, which means you would be all kinetic energy. The kinetic energy would be max. So at the bottom, mechanical energy is all kinetic. Okay, well, it still doesn't fully help me because we're looking for... no, I'm sorry, I told you read in the problem. You're going to strike the water with 7.5 meters per second worth of velocity. So if V is equal to 7.5 meters per second, and M, the mass of the person, is given as the 115, guess what you can find? You can find KE, 1/2 mv squared. Mass, 115, bring down our 1/2. And V, what is V? It's the 7.5. And we square it. So in my calculator, square this times 115, then divide by 2. This gives us a KE of 3234.375 joules. Depends on if we have everyone that got them finished. Yep. So here, guys, look what I wrote. At the bottom, potential energy is all max. So the mechanical energy at this point is all of our kinetic energy. So if the kinetic energy at the bottom is 3,234.375, guess what? What does that mean about the mechanical energy? It has to be the same. So ME is, well, let me just write this. ME is potential plus kinetic. Potential at this point is 0. Kinetic is 3234.375. So your mechanical energy So at every single point, PE plus KE need to equal that number there, that 3234.375. All right, so knowing that, you can find out what the kinetic energy is here. So again, mechanical energy, potential plus kinetic is going to equal my mechanical. My mechanical needs to be this value. The potential energy at this point is 215. To get KE by itself, we need to subtract by 215 from both sides. And this will leave us with KE is equal to 3019.375 joules. And that is your final answer. So to recap, what I did, all right, this stuff, if you understand this, the work for it is very, very simple. You're taking 1/2 mv squared. If you know at the bottom it's all that, potential 0, it's got to equal that number at every single point. Take that number minus the other. So I literally did KE and subtracted from 215. All right, the reason why the problem took so long is because I wanted to break down the understanding components of it. Mechanical energy is potential and kinetic. All right, once you know it, it's the same at every point. At the top, when you're not moving, kinetic is 0. At the top, all right, you're at your max height, potential energy is max. So at this point, mechanical energy is all potential. Like I said, if we knew the original height and we were looking for velocity, we could figure all of that out. But we weren't. They gave us the speed at which they hit the water, along with m of 115, we could figure out potential, all potential. I'm sorry, we can figure out kinetic. And mechanical energy is all kinetic right here because the height would be equal to 0. So do the equation, subtract it from PE, and that will tell you what this would need to be in order to get the number back up to that.